is, as the roller coaster raises the 2,000 kilogram train to the top of the 41.1 meter hill, how much energy is stored? Okay. Now, there's a couple ways you can look at this problem.
Wait, what is that number?
You can look at it from the top.
2,000, mass is 2,000, height is 41.4. And this is why my .0441 was messed up, because 41.4 is from last Friday when we were talking about the hill.
All
right. 2,000.
2,000 what?
So mass is 2,000 kilograms.
What is the thing like that?
Okay, what thing?
So you spell
What?
mass twice.
Yeah, I wrote twice because it's the same train. Okay. Mass is 2,000. The height of the hill is 41.4 meters.
Okay, right.
Okay?
Understand.
What?
You got math stuff up here.
That's 200.
I don't know. Thank you.
Wow.
Maybe I should.
We should have asked for
Maybe, Rex. There we go. So, mass is 2,000 kilograms. The height of the hill is 41.1 meters. So the question is, how much energy is stored? Okay? Now, one way of doing this problem is we can look at this equation. W equals negative change in potential energy.
Show you.
Right? Now the question is, what W are we worried about? Is this the work done by the motor or the work done by gravity?
Gravity.
Okay.
The motor,
Nope. Guys,
the people in the train.
this is a very important concept, and I want to make sure that we're paying attention, because if you just gloss this over, you're missing kind of a key point of this equation. All right? This W right here, this work, all right? This is the work done by gravity, okay? Not the work done by the train. In this equation, it's the work done by gravity, because what we're storing here, as we change the height of the train, what we're storing is something called gravitational potential energy. It's the energy stored against gravity. Does that make sense? Okay? If it was elastic potential energy, that'd be energy stored against a spring or changing the shape of an object. Alright, it's like when you pull back a bow and arrow bow. Alright? You're storing energy in the bow. Okay? If it was electromagnetic, that means you're bringing two charges close to each other, so it'd be the work done by those two charges. But in this case, we're working against gravity because this is gravitational potential energy we're talking about. We're changing the height. So this W is the work done by gravity. So is this work positive or negative? Negative work. Okay? Because the force of gravity is down and the displacement is up. Force of gravity is down, displacement's up. So that means the work done by gravity here is negative. So what that tells us is, as I move the roller coaster up here, I'm not taking energy away from the system. Okay? What are we doing? We're storing energy in the system. We're putting energy in. Right? So this negative sign is it just shows the relationship between the work done by gravity and the storing of the energy. Okay? Does that make sense? As we store energy in the system, we're working against gravity. That's what the equation tells us. Okay? So just have to remember at the end. Alright, so our change in potential energy, work equals mg final, mgh final, minus mgh initial. And that's got a negative sign up front. So what's our initial height? 0, right? What's our final height? 41.
0.1.
Okay? So since initial height is 0, that part becomes 0, doesn't it? Okay? And we end up with the work done by gravity, which was actually negative work, right? Equals negative mgh final. What can I do with my two negative signs? We can just cross them out, right? They become positives, don't they? So then I just end up with an equation where I'm using mgh, right? What does that equation look like?
Letters.
Okay, good. The PE equation. Because whenever we're talking about storing energy, what we're really doing is we're figuring out the potential energy of the object at that point. So instead of looking just at this equation, right, I can just remind myself, working against gravity, so I don't worry about my negative sign, starting at 0, so I don't worry about my initials, right? So all I'm really doing is I'm finding potential energy. So whenever we're asking about energy stored, especially gravitational potential energy problem, all you need to do is mgh. P equals mgh. What's the mass of the roller coaster train? 2,000. What's the gravity? 9.8.
You
What's
won
the height?
200 again.
I did. My goodness. What's the height? 41.1. So 2,000 times 9.8 times 41.1. Can you guys figure that one out?
805560.
What is it?
805560.
805560 joules. Rex, you are correct. Nice job, Rex. So that is the potential energy, guys. Guys, that is the potential energy stored in the roller coaster train by lifting it to that height. Does that make sense?
Yeah.
Any questions?
Nah.
No? Okay. While I pass out the tests, I would like you to work on example 18. Okay? So take a look at example 18.